Now, in our previous lesson video, we learned about the fundamental trigonometric identities, and we also learned on how to use those fundamentals to simplify trigonometric expressions without using tables. Now, let's recall ourselves on those fundamentals where we have sine squared theta is equal plus cos squared theta is equals to 1, and if we divide all through by sine squared theta, we will have 1 plus cot squared theta is equals to cosec squared theta, and if we divide the first expression by all through by cos squared theta, we will have that tan squared theta plus 1 is equals to sec squared theta. So these are the fundamental trigonometric identities. Now I want to look at something very interesting. We want to consider the sum and difference identities. The sum and difference identities. We will have expressions such as sine A plus B. We will have expression as sine A minus B, cos A plus B, cos A minus B. Similarly, we will have tan A plus B and also tan A minus B. So without further ado, let's get straight to business. Let's write out the expression of sine A plus B. We'll skip the derivation part so as to not give ourselves the bulk load of expression. So sine A plus B is equivalent to sine A cos B plus cos A sine B. So what do we notice here? We notice that we have sine A cos B, then the same A is being changed to taking the cosine, and B, which was cosine first, is now sine. So we have sine A plus B to be equals to sine A cos B, and being added to cos A sine B. Now if we say let's replace B with minus B, replace B with minus B. So wherever we see B, we change it to minus B. So this will give us sine A plus minus B, because there is a B here, is equals to sine A cos B. We'll change it to minus B, plus cos A sine, we'll change this B to also a minus B. Now this will bring us to the concept of positive angles and negative angles. Now we understand that in positive angles, the angles move from this positive zero region, that's the positive x-axis, in an anti-clockwise direction, positive angle, and in the negative angle is moved from the zero region in the clockwise direction. We'll have negative angles. So in view of this, let's see which angle it falls in which quadrant. So we know that this is the first quadrant, the second quadrant, the third and the fourth. Likewise, we have the first quadrant, the second quadrant, the third quadrant and the fourth quadrant. And in the first quadrant, all trigonometric identity is positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent, and in the fourth quadrant, only cosine. So with this now, we can come to a conclusion that cosine in the negative axis, that means we are considering this place, that cos minus theta is equals to cos theta, because here cosine is positive. Likewise, sine minus theta is equals to minus sine theta, and tan minus theta is equals to minus tan theta. This is because the negative angle falls in the fourth quadrant, and in the fourth quadrant only cosine is positive. So moving on, we can now simplify this to give us sine A, this will give us minus B, and we'll have sine A cos minus B is the same thing as saying cos minus theta. And if cos minus theta is cos theta, then cos minus B is cos B. Plus cos A, then let's simplify sine minus B. Sine minus b, in the same way, is saying sine minus theta, and sine minus theta is minus sine theta. Therefore, sine minus b will be equivalent to minus sine b. Therefore, we are saying that sine a, let's use a red pen now. By using sine a minus b is equal to sine a cos b minus, because of this negative, minus cos a sine b. So we have simplified for sine a plus b and also sine a minus b, and these are the expressions. Now let's move on to cosine, the cosine expression of cos a plus b. Cos a plus b is such that we will have cos a cos b minus sine a sine b. So we have cosine of a multiplied by cosine of b minus the sine of a multiplied by the sine of b. Now to get cos a minus b, now we do the same thing we did here, where we have to replace b, okay, with minus b. So replacing b with minus b, duplicate this, then we'll have cos a minus, this will become plus minus b, just as we had earlier, will be equals to, wherever we see b, we put minus b. So we'll have cos b to be minus b minus sine a multiplied by sine into minus b. So interestingly, cos minus b is same thing as cos minus theta is equals to cos theta, and sine minus theta is the same thing as minus sine theta. So applying that here, we have this to give us cos a multiplied by cos b minus sine a multiplied by minus sine b, and this will be the expression of cos a minus b. So to simplify further, writing it with red pen, we have cos a minus b to be equals to cos a cos b minus will multiply this minus and we'll have positive, so we'll have plus sine a sine b. Now we have found for sine a plus b, sine a minus b. I've also expressed for cos a plus b and also for cos a minus b. So we have the values for cos a plus b and also cos a minus b. Now let's simplify for tan a minus b. Now to simplify for tan a plus b or tan a minus b, let's remember the reciprocal functions. The reciprocal functions, especially tan, it explains that tan theta is equals to sine theta divided by cos theta. So we are saying that tan a plus b will be equals to sine a plus b divided by cos a plus b. So let's begin. What is sine a plus b? Sine a plus b is what we have here. That's sine a cos b plus cos a sine b. Sine a cos b being added to cos a sine b. And what is cos a plus b? Cos a plus b is cos a cos b minus sine a sine b. So we have cos a cos b minus, okay, sine a sine b. Now to get this logic very interesting, we have to divide all through by cos a cos b. So we are going to divide the numerator and denominator by cos a cos b. Remember, this is tan a plus b. So let's divide all through by cos a cos b. So we'll have sine a cos b being divided by cos a cos b plus cos a sine b divided by cos a cos b. That's the numerator, and the denominator now will have cos a cos b being divided by cos a cos b minus sine a sine b being divided by cos a cos b. Now in view of this, now we can now simplify further with the understanding that tan is equals to sine okay, over cos. So let's begin. We have sine A cos B being divided by cos A cos B. We can see here now we'll have cos B nullifying cos B. Similarly, we have cos A nullifying cos A. Cos A will nullify cos A, likewise cos B will nullify cos B. So we are left with what? We are left with sine A divided by cos A plus sine B divided by cos B, all divided by 1 minus sine A divided by cos A multiplied by sine B multiplied by sine B divided by cos B. Now we are going to apply that tan theta is equals to sine over cos. So I can simply say that tan A is equals to sine A over cos A, and also tan B is equals to sine B divided by cos B. So in view of that, I have tan A, I have tan B, and as I have tan A and tan B. So let's simplify further, and this will give me, let's use the red pen now, tan A minus or plus tan B divided by 1 minus tan A tan B. So this is an expression for tan A plus B. So we have tan A plus B. Now to get an expression for tan A minus B, so all we just have to do, like we do, is to replace B with minus B. So replacing B with minus B, wherever we see B, we change it to minus B. We'll have tan A plus minus B is equals to tan A plus, wherever we see B, we change it to minus B, plus tan minus B, and this will be 1 minus tan A multiplied by tan minus B because of B here. Now we have to go back again to see what is the expression of the negative angle of tan. So we have that tan minus theta is equals to minus tan theta. So in view of that, we go backwards forward, and we'll say this will give us tan A minus B, and we'll have tan A, tan minus B is the same thing as minus tan B plus minus tan B, okay, divided by 1 minus, so we'll have tan A, tan minus B here will result into minus tan B. So we can now have a final expression of tan A minus B, which is equals to tan A, positive and negative is multiplied to give negative, minus tan B divided by 1, this negative will multiply this negative to give positive, and we'll have 1 plus tan A tan B. Now we have an expression for tan A plus B and also tan A minus B. So that means we have been able to simplify sine A plus B, sine A minus B, cos A plus B, cos A minus B, tan A plus B, and tan A minus B. So in our next lesson video, we will take a look at the examples that involve the sum and difference identities and how to apply them.